example, if you have these Alkire-Foster methodology, its extensions, what you can do, different things, what you cannot do, what you should be careful about, yeah, some robustness test and so on. So we'll discuss all these things. In the afternoon session, we will have a tutorial. Again, we will show you again certain additional things that we could do with this measure. And then finally, in the evening, in the last session, last 2 hours, we'll have a splitter session where I will show you how to compute this measure and again what you can do and plunge. Anyways, okay. So these are the references for you. Do that. So I'll be covering from various chapters, yeah, chapters 4 to 9. So not just one chapter. I could have done chapter by chapter, but then that would require an entire summer school, not a 1-week course. So I will be drawing time to time. I will try to mention, but I will be drawing from chapters 4 to 9. Again, were you able to access the book online? Yes. So all the chapters are there available. Chapters 4 to 9, they're available as well. And this is the original paper of Alkire and Foster, which is also discussed in much more depth in chapter 5 of the book. Yeah. Okay. To start with, what is counting approach? So when we were writing the book, initially the idea was to write the book only for this counting approach, the Alkire-Foster approach. And then when we were writing, I was coordinating the book. And when we were writing, we did a little bit of study. It was done especially by my colleague, Mariana Santos. And when we were trying to look at some of the history of counting approach, we were quite surprised. We didn't know that it has already been used for so long. Of course, it was not in the mainstream. Mainstream was just consumption, expenditure, and income. But then we were quite surprised that it has been used so much. So earlier, we had the plan to write a short paragraph on counting approach. But we ended up writing an entire chapter on counting approach. Yeah, again, this is chapter 4. I'm not going through the entire chapter, but if you are interested, the history of the counting approach is discussed in that particular chapter. But yet, just to give you a snapshot that it has used in social inclusion as early as 1974. Basic needs approach also, they use counting approach, counting in how many different indicators you were determined and so on. And applications in different parts of the world, starting with Europe, Townsend, Mack and Lansley, they applied in Britain. In Latin America, it has been applied in Chile, Argentina. In Asia, it has been used in Lebanon, Iraq. I was talking about Kerala's below the poverty line identification, used a counting approach earlier. It was different from the rest of the India Windmill approach. Yeah. UNICEF created their child poverty measure. Somehow they just differentiate, they just call their analysis as MODA. Have you heard about it? MODA. So it's multiple overlapping deprivation analysis. That is counting approach. It is no different from the typical counting approach methodology. But then NGS such as Grameen Bank and BRAC has also used the counting approach. So the counting approach, if I look at the history, it's quite large, but no one axiomatically before this particular paper of Alkire-Foster, they didn't provide the axiomatic foundation. And this is what we are discussing, right? People use these different poverty measurement methodologies, whether it is fuzzy set, whether it is statistical approaches, but without understanding the foundation. Understanding the foundation is very important, so that I should be able to say, if I take this policy, this is what will be the change in poverty. Subgroup consistency, for example, if you have improved poverty in certain dimensions, you would want the overall poverty to move in that direction. If it just moves in other direction, as I told you when we're talking about these endogenous weights, PCA weights or factorial analysis weights, if you use them, they do not satisfy monotonicity or subgroup consistency. What does it mean? Situation of the poor improves, but the overall poverty also improves. or subgroup consistency, you have these two regions. Poverty in both regions have improved, but your analysis, statistical analysis, is showing actually overall poverty has gone down. What's the point in that kind of analysis? Yeah. Same for counting approach. Counting approaches were there, people used it because it was easy to understand, but no one had put in axiomatic framework studying what they satisfy and what not. So for a poverty measure, it is not just so the axiomatic framework, it is not just important to understand what they can do. It is also important to understand what they cannot do. And we will be talking about some of the sacrifices. If you choose this methodology, you have to make some sacrifices. If you are willing to make those sacrifices, you can use this measure. If you are not willing to make those sacrifices, you have to make adjustments. You cannot use it. Okay, so we cannot just bring any methodology and put it anywhere. Okay, if I go and buy a dress that is not my size, of course it is not going to fit me. And if I try to fit it, you know what is going to happen. That's the idea. Yeah. Okay. So, what is counting approach overall? What we do when we use counting approach? How do we? What are the basic steps? So these are the basic steps. We select a list of relevant indicators. Yesterday we discussed that our indicators need to serve the purpose. Okay, we need to have good discussions about what indicator we take and why we take. If we justify some indicators are not relevant, we don't have to use them. Yeah. Assign weight to consider each indicator, and you have a lot of questions how we select weights and so on. We will have some of that. Yeah, there is no unique way of selecting weights. Selection of weights also depends on your purpose and the value judgment you provide to particular dimensions. You may say that some dimensions are more important than the other. Yesterday you chose that health to be more important than education. So if you have health, you will probably choose to provide more weight, but somebody else may come and say, somebody working in Ministry of Education, no, education is more important. If you guys cannot resolve the issue by fighting, you can have a match, wrestling match, or whatever. If you cannot win, let's go for equal weight, and then you can do robustness tests. What if I give more weight on health, more weight on education? That's rankings change. I will come back to that point later. Okay. Then you have to define thresholds. We are going to call them deprivation cutoffs. That means what is the minimum level that you need? For example, in Indian context, if you are looking at say, adult education, yeah, what threshold do you choose? When you consider a person deprived in, say, level of education, years of education, what would be a reasonable poverty cutoff for you?
It was not having secondary education.
Yeah, 10. Okay. Anyone else? Would you all choose secondary education as your cutoff?
Those who cannot read and write.
So that would be your cutoff. Okay. Anyone else?
So, minimum for education or for literacy? I mean, basic as per the rule, it is 14 years of minimum education. I mean, 14 years of. Yeah. It is at least 6 years of education.
So that means 8 years of education. Yeah. Okay. Anyone else? So who would agree with, say, deprivation cutoff in basic literacy, read and write? How many of you choose that? Please raise your hand. Okay. Perfect. How many of you choose 8 years of schooling threshold? Okay. How many of you choose secondary education? Okay. So you see, so that means if I just come and choose one cutoff, I need to defend. I could have an easy option. I could just go for vote and democratic vote. Whoever you have more number of votes, I can choose that cutoff. I can choose that cutoff, that's fine. But then I also need to do robustness test, and this is what the robustness test is all about. Because different people can have different point of view. You also compute and then check. Really, is it changing your poverty ranking and all these things? Yep. Now, I also work with a particular organization, kind of a think tank, they are actually trying to push for secondary education. Yeah, the secondary education should be the minimum standard. But it was rightly said in India, by law, is the elementary education where the focus is. Now, there was a reason why elementary education was chosen. Because elementary, year age 40, according to the definition of United Nations, anyone from 15 year or more, they're considered adult. They're eligible for work. For child labor, the law is that it's 14 or below. So that's the reason why the ministry has chosen it, but it's not set in stone. Now today, if you are living in a city, Delhi, Mumbai, Kolkata, minimum 10 years of education is mandatory. You cannot literally do anything without 10 years of education. Yeah, in the US, they say that's 12 years of education, minimum. So you see, with social standard, it's kind of relative poverty. With social standards, these deprivation needs to evolve. So, when you are choosing this deprivation cutoff, it's not just easy. If you look at MPI, the global MPI, they use 6 years of education because it is equivalent to primary schooling. But India has moved on. If in 1970, literacy were relevant in 1950s, 1960s, because illiteracy rate was 60%, 70%, right? So setting literacy as our goal, being literate as our goal would have made sense. Today, if you say literate or not, you'll probably have almost close to zero deprivation. The question is, then is it relevant? See? So that's how deprivation cutoffs needs to be justified. Whether you do it for health, education, assets, sanitation, everything. Yeah. In global MPI, when we're deciding the cutoffs, we had to follow the Millennium Development Goal definitions. Now, if Sustainable Development Goal has moved on, cutoffs need to be adjusted. Yeah. So once you have defined the threshold or deprivation cutoff for each indicator, create a binary deprivation score where 1 means deprived, 0 means non-deprived. Okay? The 0-1 matrix.
So can we say that this deprivation cutoff depends on the current living standards or current?
You cannot just, you have to go, and it is not just current living standard. You have to go to the literature, you have to justify properly. And it is possible, just defending one particular deprivation cutoff may take you 1.5 pages of writing. It is not just depending on current standard of living. Even the current standard of living of 8 years of India, I don't agree with that. I think it should be 10. But if I try to do 10, I may be conflicting with some other rights where people say you are conflicting with the right to work. Because at 15, the child labor law does not apply. So at age 15, somebody has right to work. So if I say minimum standard of 16 years, it will take up till 16 years. Somebody may come and say, well, you are conflicting with right to work, and that's why I do not want to do it. It's not about what is currently prevalent. You have to take all these other aspects into account and has to be debated. Does it make sense? It is not just, it looks like straightforward. Oh, I have this data. Oh, I have this cutoff. I put it, and then I have done a poverty measure. It doesn't go that far. You need to be able to defend them properly. Make sense? So then once you have these 0-1, you assign these binary values, you produce a deprivation score by taking a weighted sum of deprivations. I will go them step by step. I'm just explaining the steps that I will follow. Then finally, you say the poverty threshold, so that a person is poor if the person's deprivation score, weighted deprivation score, is on or above this particular threshold. That's how you identify a person as poor. Now, the distinction between deprivation and cutoff and poverty cutoff is very crucial. Yeah, deprivation cutoff involves a particular indicator or dimension. Poverty cutoff is something you assign after you have aggregated all the deprivation score for each individual. So poverty and deprivation doesn't mean the same thing here. You may face deprivations, but you may be not poor, or you may not have some deprivations. You may be identified as poor. To come to that, yeah.
So when we have all forms of deprivation, then what the poverty?
Let me come to that point. Yeah. But if you just look at here, these are deprivations. I did not say poverty. Here you have to have two cutoffs, deprivation and poverty. They are the same. Whether how we identify them, I'm come to that. Please bear with me another 10-15 minutes. Okay. So advantages and disadvantages. It's fine to just discuss upfront. Of course, counting approach allows you clarity, a bit more transparency to look at and identify the multiple those who have multiple deprivation. It allows looking at joint distribution. Why? Because you are counting the deprivation. So you are looking at jointly. So you are looking at their joint deprivation. This is a column first or row first? Row first, because you are looking for each person, you are aggregating their deprivations. Does it make sense? This is how you look at the joint distribution. This is how row first look at joint distribution. Does it make sense now? So it allows mixing of cardinal and ordinal variable. Some counting approach, but it could fail as well, and I will come to that at the end of today's lecture. Disadvantages, some people call it disadvantages, but some of them can be argued to be strengths. It relies on a particular selection of indicator for particular purposes. Some people say it's disadvantage, but it could be seen as strength as well. That's true for many other cognitive measures. Relies on weights assigned to dimensions and indicators. It has been criticized, but then the idea is that limits to robustness test. There is no perfect way of choosing weights. If somebody comes and tells you this is the ideal way to choose weights, that person is or academician is lying. There is no perfect way of choosing weights. Every possible weight you choose, whether it is normative weight, statistical weight, however you decide it, they have their inherent arbitrariness inside. Nothing is perfect. Even the prices that you use, right? What do people argue? Oh, in multidimensional measurement, you choose weights, right? And when you do consumption expenditure, your price is given, you use prices as weights, right? How often, how far do you adjust the price variation when you are computing the consumption expenditure of Gujarat? How many different prices do you use? Prices vary. If you buy Hindi here, it's 10 rupees per kilo or what? You just go to a neighboring town, it is more expensive. So how frequently do you adjust for these prices? How accurate are they? You make some assumptions about weights there too, about prices. Nothing is perfect. Okay. Now, this one definitely is a big one, relies on dichotomies of deprivations. It doesn't capture depth for identification, but it has other problems, other issues as well. I will try to discuss some of them at the end here. And this one is true that sometimes counting approach is combined with some aggregation methodologies that are not intuitive, and they also assign this cardinal and ordinal meaning to values. Okay, and this is something we discussed in our ordinal poverty measurement lecture, right? They just take that 1, 2, 3, 4. So sanitation, they are the 1, 2, 3, 4. I don't know if you have noticed. And they use that to create gaps, create square gaps, although the values have no meaning. So I have to be really careful about it. Yeah?
Can you say someone
Which one?
sanitation?
Cardinal ordinal? Suppose you have these sanitation categories. And in data set, how are they coded? Yeah, but in general, have you ever seen data coding of these variables? Coded as 1, 2, 3, 4, 5. And people just take those codings as if they are the real numbers. And then they apply gap, square gap, say set the poverty line to 2, 5 minus 2 over 5 or something like that. Doesn't make any sense. I will come and
numbers, no? These are ordinal like 20s.
Yeah, but people,
Uh,
yes, they are, but people use it as if they are cardinal numbers. You'll be surprised how many papers they have published in journals. They use those numbers as those ranks, the ordinal categories as numbers, as if they make real sense. That's wrong. But people do it. You should not do it. But people, even using counting approach, they do that. Try to find depth using those numbers. Yeah? Yeah.
Is there dimensional monotonicity in this counting approach? Because it does not agree with the 1% term length.
I will come to dimensional monotonicity. Please bear with me 15 minutes. Do you have any question about the methodology itself? Then what is your question about?
Like the dimensional monotonicity is there in this, like when we calculate this L5 by L5 Foster.
But I have not completed L05 Foster. So let's wait a little bit. Let me show the L05 Foster methodology. So your question, you can ask your question, but those who do not know here L05 Foster, they will be confused. So let's wait for 10-15 minutes. Let me go to the methodology quickly so that everybody is on the same boat, so that when you ask a question, all of us will understand. Yeah? Hold on to your question. I'm not again avoiding. Let's hold on to it. I will come back to it in 10-15 minutes. Yeah? And I will actually talk about dimensional monotonicity. Yeah? Okay. So how do we compute these L05 Foster methodology? Again, I could go for 2 hours. We used to go for 2 hours discussing this methodology, but I don't think we need 2 hours at this moment. We can really briefly understand what this is about. I will go with an example, okay, so that it will be easier. So we have these 4 people. By the way, it's a funny thing. Whenever I go to whichever country I go to, I choose the names accordingly. Okay. So if earlier I was choosing, I forgot where I was doing. I was in Moldova, so I had all the Russian names. Okay. So I came here. I hope it is quite diverse, set of names. Yeah. So so we have this achievement matrix, and suppose we have chosen these 4 dimensions, just illustrative purposes. Sometimes people ask me, why didn't you include somebody on health? It's just examples. Okay, calm down. Okay. So we have these 4 people. We have Akash, Aisha, Virat, Maria, and then we have these 4 different indicators. Yeah, we have their achievements given, and then we have, this is the deprivation cutoff vector. So if your income is less than 600, you are identified as deprived in income. If your education is less than 12, suppose we had a discussion like day 10. If it is less than say 12, you are education deprived. If you do not have sanitation, you are sanitation deprived. If you do not have access to electricity, you are electricity deprived. Okay? So the question is then first, who is deprived in what? So we are going to replace by 1 if deprived, by 0 if not deprived. Make sense? So that's the first part. So we use 1 whenever an achievement falls below the deprivation cutoff. It makes sense? These were below poverty line, so they were deprived. These are education deprived. Virat is the only person who is sanitation deprived, and Ayush and Virat looks like they both are deprived in electricity. Okay. Now there is a concept called uncensored headcount ratios. What is uncensored headcount ratios? It is the proportion of people who are just deprived in each indicator, irrespective of other indicators. So if you just simply ask, okay, in my data set, how many people are income deprived? 2 out of 4. Right? So the uncensored headcount ratio of income is 2 over 4, 50%. Uncensored headcount ratio for education, again 2/4, 2 out of 4. Uncensored deprivation of sanitation, 1 out of 4, and the electricity 2 out of 4.
Can you just repeat what is uncensored?
I have not done any censoring, have I?
No.
They're all just raw data. So in raw data, you just ask how many people or what fraction of people are deprived in each indicator.
That means we are not making any censor. That is
We have done just raw data, and I'm just asking you, based on the raw data, in your data, what fraction of population has deprivation in income? What fraction has deprivation in education and so on? We just give it a name because later we'll be doing censored deprivation. And unless we add another name, you will get confused or people get confused. So we just call it uncensored. We used to call, in early days before writing the book, we used to call it raw censored, raw headcount ratio. Raw sounds a bit awkward. So we decided to replace it with uncensored. Okay? Okay. Now we are going to assign weights. Now suppose again through democratic process or however it is, definitely not using principal component analysis, we come with some weights. And we are saying that education is the most important. We are giving half of the weight to education. We are giving 25% of weight to income. And we are dividing that rest of the 25% weight equally between sanitation and electricity. So we have income receiving a weight of 0.25, education 0.5, sanitation and electricity, they are getting 1/8, 0.125. What we need to do, we multiply each deprivation by the corresponding weight. So 0.25, 0.25, 0.5, 0.5, 0.125, 0.15, yeah? Now, if you had equal weights, you multiply by 0.25 all the dimensions. If you have equal weights, that means 0.25, 0.25, 0.25, 0.25, you multiply all of them by 0.25. Okay?
So the sum of the weights needs to be what?
To you. So if you go to the book chapter 5, we show 4 different scenarios. In one scenario, if the weights sum up to 1, what would be the formulation? What if the weights sum to the number of dimensions? You have a formulation for that, and so on. So in the book chapter, if you go, chapter 5, at the end there is an appendix. And in that appendix, you literally have information for the formulation for all possible, whether when you sum it to 1, if they don't sum to 1, all of them. But here, I'm just doing it sum to 1, so it's much easier to understand. Bless you.
How have we assigned those weights that income will be 0.5, education will be 0.5?
Normatively.
Non-mathematical.
I just woke up in the morning and I felt like education is more important.
We have to justify it, right? So
Sorry?
we have to justify it.
No, I felt I'm bored. So I just did it. Kidding. Listen, yesterday I made a vote, right? I asked you, okay, which of these 4 indicators you feel more? Who feels education is most important? Raise your hand. Of these 4 indicators, who feels education is more important? Okay, some of you. Who feels income is the most important? Some of you. A bit more. Fine, you're winning by income support margin. Who feels sanitation is the most important? More important? Okay, most important. More important than education and income themselves. You see, each teacher, right? You are visited here, right? And then who feels electricity is the most important? Some of you. So look, you all have your justifications, right? So at the end, what I will do, I have chosen, because in the morning after having the tea, I felt like doing it, but I need to conduct robustness test. Make sense? Any weight I come up with, you will be sitting there asking me, even if you choose one weight today, buy something, next morning you will be questioning yourself. This is how it works. So that's why robustness test and dominance test are so important. Okay?
Does it not is the matrix of
G0, this is G0 bar. So G0 is called the deprivation matrix. So in the previous slide, you have 0, 1, right? So they are called deprivation matrix. And this one is just weighted deprivation matrix. Yeah. So weighted deprivation matrix. So it's G bar, but the bar for some reason in PowerPoint it just doesn't show the full length. You have a
follow-up question.
Yeah, sure.
If I want my index value to lie between 0 and 1, shall the sum of weights must be
It will be, what do you want to be 0 and 1?
my overall deprivation index?
You want your M0 index to be between 0 and 1.
So in that case, can I
It does not matter whether you take weight sum to 1. It does not matter whether you take sum equal to weights equal to B or whatever. M0 will always lie between 0 and 1. You just have to adjust your formulation. They all are given in that. That's what I'm trying to say. So M0 will always be between 0 and 1. Whether your weight sum to 1 or your weight sum to number of B, you just have to adjust. How exactly you have to adjust, that formulation is just given in the appendix. That's what I'm trying to say. Is that what you are asking? Yeah. So even if you take weights not summing to 1, your M0 will still have the same value.
I need to make some adjustment in the problem.
You just need to make, and again, we know that this is a problem. This would be a problem. And that's why we have provided the appendix with every, I myself has wrote all of the formulation, and I can assure you they are correct. Okay? Chapter 5, where you have
Sorry, silly question, what is M0?
adjusted vector. We'll come to that. That's why I was holding on to a lot of questions. There's a lot of question about the methodology, and I wanted to go through the methodology first. Yeah? Burning question. Yes. About what?
So the assigned weight will be the universal or it depends on the data or
Say it again.
the weight we assign to
Yeah.
a specific indicator will become a universal that will
What do you mean by universal?
universal means that if there is a like a different demographic which I'm using it in UP, then I use it in some other place. That same weight I can use for the
That depends on the objective of the measure. So when you construct a measure for say India, you want to track progress of different states, right? Yes or no? If that is your objective, you use two different measures, the one for Bihar and one for UP. How do you compare them? Does it make sense? So, in general, answer lies in your question. So, objective. Now, if you are designing something for, you say, Rajasthan, you created one and used equal weights, right? What if different districts have different weights? Would you then use different weight for different districts? So it all depends on your objective. Now, if you need to, say you create one measure for people from the tribal region. You make one measure for people living in mountains. Of course, then you will assign different weights because they have different needs. But then people living in the entire mountain chain all have to have same weights, otherwise they are not comparable. That's the idea. Does that answer your question? Yeah. Yeah.
Sorry. So my question is that what is the proposed check of our we have like for the like we have decided some kind of on the basis of our judgment that this is serious for me, so I will be more going to that and all. Then when we want to robust checkness, that in that case can we go some questionnaire or some questions in our questionnaire for our samples that what they prefer, which one is important for them,
You could.
or
But you know, understand that if you interview 100 people, all of them will have different weights, right? You will have 100 different weights, right?
It can be like, can we say like if 50 more than 50% people are talking about one case is serious?
Again, you are defining democratic rules. This is exactly what I'm talking about. So it's totally up to you. Empirically, whether it is more than 50%, whether more than 30%, it's totally up to you.
Aligning to this is case where we can go for primary survey and we have that part to make the question. But when we are going with like NSS or NSS on this sort around that, in that case, can we go with the responses what they have responded, how serious the issue is, and from
In a sense, you have that kind of information.
No. Sir, I'm not like, I'm just assuming that if that kind of scenario, we can think any aspect of related to that, of like how you will think which 5 is serious and how we need to robust check that because in secondary data.
Okay, let me ask you something. Suppose in a democratic decision making, we are making vote. Yeah. 99% of people have supported for the option B. 1% of people has supported option B. So majority of the population has supported A, 1% has supported B. Would you go and say those who supported B, they are not serious? How, I mean, how?
But we can say that is less serious.
No, we cannot. That's wrong. Majority of people have preferred, a particular food or what choice. 1% did not, but that does not mean that 1% less serious. How can you do that? A number, just putting number weight. If you do that serious, what you are saying, we are going to suppress your voice. You guys are not serious. That's wrong. You cannot do that. That's what I'm trying to justify, for the entire module. We cannot do that. We cannot come and say just because most people support it, it is more serious, and less people support it. Many of my voices, many of the things I say to you will be less serious because majority of people may not agree with me. Most people think income is most important. Other dimensions, they should not receive any weight. So our voices are actually less serious. We cannot do that. So for robustness, you have to take all of them seriously and then try to do robustness test based on a particular set of weights. That's what it is. Does it make sense? Yeah. Okay. So next step, what we will do, we will add up all these weighted deprivations. Yeah. And to get a deprivation score. So this is what we get. So we just added up all the weighted deprivation. So Aisha has received a score of 0.375. Virat has got a score of 1, right? Because weight sum to 1 here. And Maria gave a score of 0.5 itself because education itself carry a lot of weight. Okay? Question now is identification. Who we should identify as poor? We have identified the deprivations, but who will be identified as poor? That's where we need a poverty cutoff. So we are going to censor. Remember, we censored at the poverty line in case of income. Here also, we will do a kind of censoring. Those who are non-poor, we will censor. We will assign a different value. Now, there are these 3 different approaches. I briefly mentioned them. What is union approach? For union approach, you are going to set the poverty cutoff, which is going to be less than or equal to the minimum weight. That means you are identifying, you are literally saying, even if you have just one deprivation, I will identify you as poor, multidimensionally poor. Generally, you can apply that rule for rights-based approaches. If you are defining your indicators as some basic rights, even if one right is violated, you are going to be saying that person is poor. Right? For intersection approach, is the intersection is not that the word comes from the set theory, is the intersection, right? The intersection approach, that means you are poor if you are depriving all dimensions at the same time. So how many people will be poor here? Only one, right? As a score of Virat is poor. So if it is union, how many people will be identified as poor? 3 of them. Then you can have an intermediate approach. So you are saying, yeah, you must have at least 50% of weighted deprivations. If you do that, how many people are poor? 2 of them. Yeah. Now let's look at the practical side. So this is a data that I and Sabina worked in 2009, even before MPI was created. We were just playing with the data. We were playing with the NFHS data. Yeah, so we selected 10 indicators and we tried to see, okay, how many people are deprived in how many indicators. So when we use a union approach, if you look at these 2 approaches, when you have a union approach, we found 91.2% of the population to be identified as poor. For intersection approach, none. So imagine I told you the story that we came up with this multidimensional poverty index and 53 7% of people were identified as multidimensionally poor. Indian government said, "Are you crazy? Our poverty rate, income poverty rate is 27%, and you are making it 54%. Now imagine if we had gone and told they were not actually 91% of the population poor, what they would have done. They would have thrown it in the dust. So there's practicality problem. We cannot just come with union because, and also I told you the problem of union. Yeah, because if you have just one deprivation, that could be measurement error. That could be by choice. That could be many reasons. So why don't we at least have at least a number of deprivation to be identified as poor? So Indian government, if we had asked Indian government at that point of time what cutoff we choose, they would have suggested probably 4 because that was closest to 27 points. 27% of the income, prevailing income poverty rate or something like that. Anyway, but this is again, these are not, all of them are MPI indicators. Most of them are similar, but not all of them different cutoff because it relates. One is union, this is intersection, all of them are intermediate, 2 to 9. Intermediate, that means between union and intersection. All of them are intermediate.
The way will it will be at least one, I think, at least one will. What was that?
Either 2 or more deprivations, 3 or more deprivations, 9 or more deprivations, 8 or more deprivations, anything that is not 1 or intersection. For 10 indicators, 10 will be intersection, 1 will always be union. Anything between 1 and the intersection will be intermediate. Yeah, so poverty threshold would be 2 poverty thresholds. So for each poverty threshold, you have the proportion of 4 people. Each poverty threshold, you have the proportion of 4. How many people are deprived in 3 or more dimensions, 3 or more indicators? 4 to 4. What fraction of population is deprived in 4 or more indicators? 33.3 and so on. Yeah. So 91% of the population will be targeted using a union approach. No people poor in all 10 indicators, so intersection approach. Neither of them would be practical to implement. Yeah. So we probably need something in the middle. What should we choose? We didn't decide on that paper, but for MPI, UNDP, they used 33%, 1/3. But it has its own, people criticize it for different reasons. I will come back to that later. So this is called a dual cutoff approach because you have a set of deprivation threshold and you have a set of poverty cutoff. Yeah, deprivation, but we have 2 different types of cutoffs. That's why they are called dual cutoff approach. Okay. So let's now move forward with the methodology. So suppose the poverty cutoff is k equal to 0.5. Yeah, suppose we take that as our intermediate cutoff. We have union, intersection, let's take an intermediate cutoff, 0.5. So what you will do, whatever poverty cutoff you choose, you need to censor. Remember, we chose the poverty line and then we censored the income vector. So those whose income were on the poverty threshold or more, we replace them by Z, right? Yes, do you remember? Here, if your deprivation score is more, then your sort of extent of poverty goes up, right? So here, we have to do the censoring at the bottom. So if you are not poor, you may have deprivations, but you are not poor, you get a censored deprivation score of 0 because you are not poor. So although Aisha has deprivations and the total deprivation score is 0.375, but given that it is below 0.5, we replace it by 0. So that's the censoring. Okay. Now, what is the interpretation? The way you should say that one is poor if deprived in 50% or more. It should be 50% or more. I don't know why it's getting said in the morning. So it has to be 1 is poor if deprived in 50% or more of weighted indicators. Okay, I will revise it. I think this will be revised in other slides, but not here. So 1 is identified as poor if the person is deprived in 50% or more of weighted indicator. This is how you should write it down. Yeah. Sorry. So it is 0.5, right? So if you look at these two, they have 0.5 or more, right? Make sense?
Yeah.
So you have Berat and Maria, right? So they are poor in 50. Here you go. It's written here 50% or more. It should be same here 50% or more. Yeah, 50% or more of weighted indicators. Is this clear? Why they both are poor? Yeah. Okay. So now that we have identified who are multidimensionally poor, same as in the income case, right? This is the reason why we went through the single dimensional income world, right? It makes life easier for you to understand. So we have sensor deprivation score. Let's move on to the aggregation stage. Okay. First, we compute the incidence of multidimensional poverty, which is the multidimensional head count. You know what head count ratio is by now, yeah? It just asks what fraction of population is multidimensionally poor. How many people are multidimensionally poor here? What fraction of population is multidimensionally poor?
50%.
50%. Great. So your incidence of multidimensional poverty is 50%. Okay. What is the intensity of poverty? Intensity of poverty is the average deprivation score among the poor. What is the average deprivation score among the poor? You have two poor people.
75.
0.75. So 75% of weighted deprivation. On an average, this is the case. Yeah. Now look, this is quite similar to what we did for poverty gap. For poverty gap, we computed the headcount ratio, but then we took the average of normalized gap among all the poor, right? And then finally, we multiplied the two, the income gap, average normalized gap among the poor, and headcount ratio that gave us poverty gap. Remember? Same thing here. Okay. Now, we have noted what is incident, what is intensity. Now, suppose Maria's deprivation increases. So now Maria has deprivation in 3 additional indicators. Okay. What is H now?
Same, 50%.
So H did not change. Okay. What is intensity? Average deprivation share among the poor, has it changed?
100%.
It has changed. So 100%. Adjusted headcount ratio can be seen as a product of these two numbers. Just like poverty gap, it was headcount ratio times the income gap gave our poverty gap, right? Similarly, adjusted headcount ratio, or M, equals M0, I'm just saying M here, is H times A, which can show to be just 1 over N and sum of all these numbers. You just take sum of all these 4 numbers, the censored deprivation scores, and divide by the number of people, 1/4. That gives you H
intensity.
This number of people is equal or not?
Sorry?
Total number of people are close by equal.
N, all, everywhere. 1 over N, and then this plus that plus that. Okay?
What is A?
Intensity.
Share among the poor. Okay? So, your M0 is simply a product of these two numbers. Or it can be alternatively computed as just the average of all these numbers in this column after censoring. Okay, so M0 can be calculated in these different ways. Question?
What is the answer? Means what is the answer for this?
What is the?
Just a head count ratio.
You want the answer? Yeah, it will come. I mean, why are you worried? Let's understand the methodology first. Numbers will follow. Numbers mein rakha kya hai? Okay, so this is your M0. So you could either compute them. So M0 is actually 0.375 because I computed not from here. So the red one is from previous slides, right? Blue one is from this slide. So on previous slide, you had 0.5 and 0.75, right? If you multiply 0.5, 0.75, you get 0.375, which is nothing but 0 plus 0 plus 0.5 plus 1 divided by 4. Now you have 0.5 and 1, which is going to be 0.5, the product, which is same as 0 plus 0 plus 1 plus 1 divided by 4, same number. This is the adjusted head count ratio. Clear? Now, recall dimensional monotonicity. You had a question, right? Here, when Maria became deprived in additional dimensions, so deprivation in these dimensions went up, right? Did head count change? So head count violates dimensional monotonicity. So if a poor person becomes deprived in additional dimension, additional indicator, then poverty doesn't change. That's the violation of dimensional monotonicity. You can see it from the other side. If a poor person becomes less deprived in one indicator but remains multidimensionally poor, then poverty should change. Poverty should go down. But if it does not, just like head count ratio, it violates dimensional monotonicity. What was your question about dimensional monotonicity?
This was the question that doesn't decrease when the poor person becomes less.
And it's the other way around, the same thing. The poor person becomes more deprived, poverty should go up. Poor person becomes less deprived, poverty should go down. But there you go, head count doesn't change. So head count violates dimensional monotonicity.
But so
Make sense now?
the intensity will change, right? The intensity of
But I'm
deprivation
talking about
changes.
head count ratio, na?
Head count remains the same, but the intensity
But
changes.
that's why we are going to adjust the head count ratio,
Okay.
because intensity will change, and as a result, M0, your adjusted head count ratio satisfies dimensional monotonicity, but multidimensional head count doesn't. So what is the difference between multidimensional head count and adjusted head count ratio? Multidimensional head count ratio does not satisfy dimensional monotonicity. Adjusted head count ratio does satisfy dimensional monotonicity. Clear? Second one is deprivation focus. Does M0 satisfy deprivation focus? What was the property of deprivation focus? Remember, we talked about two different properties, deprivation focus and poverty focus, right? That sounded a bit boring, but now there you go. You have the question in the exam. Do you remember what deprivation focus was? Deprivation focus was if you have any increase in the non-deprived achievement, non-deprived indicator, poverty doesn't change. What we have done here, we have already said, if you are not deprived, we are giving a value of 0. Not poor, no, not deprived. So if you have any changes in this non-deprived 0, 0, 0 indicators, there is no change in poverty. Okay? By doing that, it is using a censored aggregation, a censored deprivation approach. Sorry. Yeah? It is not an aggregation approach anymore. Yeah? It's a censored one. Okay. Okay. Now I move to, but did the methodology make sense? That is what adjusted head count ratio is about simply. That is what you need to know about all you need to know about how to construct the methodology. Is it clear? It's easy peasy. You can just go ahead and write a coding data and it will be created. Yes.
application score you got? Is it for the household or for each individual?
I don't know, whatever the limit is. You are talking me, you are asking me the empirical question. We will learn about it. We will talk about it more in our status session. In the afternoon. Is that okay? It doesn't matter. It could be an individual, could be a household.
If it is for household level, so then you put the sum command, sum of applications.
Yes.
So if we get the mean value, can we say that it is the additive value at origin level? Mean value.
Why don't I go to the status session and answer that question to you? Yeah, rather than trying to answer again. For now, let's understand the methodology, and then we will do the practical side later. Yeah. Deprivation focuses if you have any increase in your achievement in the non-deprived indicator. These zeros, why have you replaced them by zero? These zeros. So if you have any change in those dimensions, does adjustment headcount change? They are already converted to zero. So we don't care about people's achievement when in the indicators they are non-deprived. Yeah, sensor achievement approach. Okay, so now we move on to two different types of decompositions. Okay, how these, there's some of the policy relevant aspect. We have already seen that M0 can be written as H times A, right? Multidimensional head count times intensity. So now there are two different types of decompositions. Of course, they do not come by sacrificing something else. I will come back to that later. But for now, so first one is dimensional breakdown and then population subgroup decomposition. For the dimensional breakdown, what you can do, this is your M0. And these are your weights assigned to different indicators, right? So the headcount ratio, adjusted headcount ratio can be written as a weighted sum of something called the censored headcount ratio. We use uncensored headcount ratio, right? We already covered it. Censored headcount ratio, what is that? This is the proportion of people that are multidimensionally poor and deprived in that indicator at the same time. I will come with an example. Yeah. In the next slides. And then population subgroup decomposition, you have already seen this several times, is that the overall headcount adjusted headcount ratio can be written as the population weighted sum of adjusted headcount ratios of different population subgroups. So if you have North India and South India, North Indian adjusted headcount ratio with North Indian population share, South Indian headcount ratio with South Indian population share, you give the overall headcount ratio.
Indicator breakdown is the different.
I'm coming, just next slide. You just missed the next slide. Don't worry, I'm coming. Then, if you don't follow, then we will have another set of questions. Okay, I'm coming. So, this is what we had. So we had censoring. We are still using k equal to 0.5. And if you are k equal to 0.5, this is how you compute the M0, which is 0 plus 0 plus 1 plus 0.5. Right? This is what our M0 is about. Where Birak and Maria, they were identified as multidimensionally poor. Okay? Look, I have got rid of this other deprivation because this person is not poor anymore. Aisha is not poor anymore. So Aisha's deprivation, the entire thing is replaced by 0. Because we are not bothered about Aisha because Aisha is not poor. So everything is replaced by 0. Now, look at these different segments. Now I ask you, in how many, so look at income. So what fraction of population is multidimensionally poor and deprived in income? Fraction of population that are multidimensionally poor and also income deprived. What fraction of population? 1/4. So the censored headcount ratio of income is 1/4. What is the fraction of population that are multidimensionally poor as well as deprived in the education indicator. 50%, right? So if you compute the fraction of population that is multidimensionally poor and deprived in indicator at the same time, these are the values you get. Income 1/4, education 2/4, sanitation 1/4, electricity 1/4, right?
So how income is 1/4, because in income we have 0.25 and cutoff we have fixed at 0.5.
No, I have just asked you a simple question. What fraction of population? How many? It's just one, right? So it turns out if you just multiply those fractions by their weights, the fraction you have got there, you just multiply with their respective weights. Look, you get 6/16. Okay, you have the same value. So the weighted sum of censored headcount ratios is your M0 itself. Does it make sense? Do you see the picture? Yeah.
And this M0 equal to 6.5/4. It's seen as 6/16.
Say it again, please.
Sir, M0 equal to this 0 plus 0 plus 1 plus 0.5/4.
Yes.
Which is 6.5/4.
How?
1.5.
1.5, which is 6/16. It's the same, right? Because you are going more than one, and I just couldn't see how it is more than one. Yeah. Okay. So now you have created it. Now you can also ask what is the relative contribution of the sanitation indicator to M0. So the relative contribution of sanitation will be this bit, 0.125 times 1/4, divide by the entire M0, which is 1/12. So look, the contribution depends on both the censored headcount ratio as well as the weight that you have assigned. Plays a role. Both of them determine the contribution of a particular dimension or indicator. Yeah. So sometimes people say, oh, contribution of this is higher and lower, but you have to keep in mind you have already assigned higher weights. That's why it is higher. You need to acknowledge that. Yeah. Many paper I refer it. And we can see this dimension contributes the more. Well, acknowledge, given that I have assigned more weight to that dimension also. Because they're together. Otherwise, if you have equal weight, then it's fine. Whichever has higher deprivation will show higher contribution. So both of them. So contribution depends on both. Just so that you know technically. Yep. How can we use it? Well, if you have same weights, say, for different regions and different countries, this is a region from Barishal, from Bangladesh. This is Nicaragua's Jinotega. This is Senegal's Jingisho. Now, if you present, they all have same weights. So weights are not different. That brings to your question, what if you use different weights? Now, if you use one weight for Madhya Pradesh, one weight for Rajasthan, and then you try to show different compositions, well, they are not comparable. You cannot even compare. So if you want them to be comparable, you have to use same weights. Okay? So if we have used same weights, but despite using same weights, look, in Borishal, the contribution of nutrition is much higher under nutrition and mortality. The contribution of health in that sense is much higher, yeah, compared to both. Now, if you look at Jinotega and Nicaragua, look, the contribution of all access indicators together is much higher. They have similar level of MPS. Yet, you can observe different types of contribution. That's the kind of analysis that dimensional breakdown allow you to do. Now, if you want to completely forget about weights, you assign equal weights, all indicators are equally weighted, then that contribution will be here, because in this contribution, you have the censored headcount ratio as well as the weight. They all are included here. If you do not want, if you want to just have the contribution of a particular indicator, of course, one option could be to forget about weights. Don't use weight or equal weight. Not using any weight is equivalent to equal weights. Yeah. Then probably they will change. Then you will have the absolute sort of contribution of the sensor deprivations only without any weight. But here, weights are incorporated. But if you look at the contribution of dimensions, they are equally weighted because this is 1/3, this is 1/3, this is 1/3. Yeah. Does it make sense? Yeah. Any questions here?
What are those black lines indicate?
Black line so that you understand the differences properly. So these are two indicators of schooling, education. These are two indicators of health, and these are 6 indicators of standard of living. So there are 3 dimensions: standard of living, education, and health. So black line indicates the differences in the dimensions. This is one dimension, this is one dimension, they are one dimension. Yeah.
Sir, these 3 bars are for different countries.
These 3 are for
Different countries.
okay. You tell me. Borishal in Bangladesh. Jinotega is a region from Nicaragua. It's in Central America. And this is Ringisho from Senegal, which is a country in Africa, Sub-Saharan Africa. So it's not just different countries, different regions of different countries.
So you use the same weight, sir. In order to
Oh, otherwise they are not comparable.
Sir, under each dimension, we have different indicators. So, weights.
So you have equal weights, 1/3 for this dimension, 1/3 for this dimension, and 1/3 for this dimension. Then weights equally divided, so it's 1/3, 1/6, 1/6, 1/6, 1/6, 1/8 into all of them. Yep.
इसके अंदर में जो इंडिकेटर है
1/6.
1/6 and not the dimension but each indicator within the dimension has more weight than those
The asset indicators.
yes engineering is
Yeah.
and yes schooling has more weight than the assets.
Yeah.
So I mean you mentioned that if we are censoring, if we are looking for censored account rate, then we can't just say that in the education. I mean, each dimension, each indicator is not comparable in that sense
No.
because of the weights.
First of all, when you refer to the contribution, you should have in your mind that this is sensitive count ratio times the weight, right? But here, note, these two has 1/3 weight. This one, these two has 1/3 weight. The rest 1/3. The dimensions are comparable because the dimensions have 1/3, 1/3, and 1/3.
Yes.
But the indicator contribution, when you are judging, you have to keep in mind you should not compare the contribution of these and contribution of these without acknowledging that this one actually has 1/3. I have myself assigned 1/3 more weight compared to that. That's what I'm trying to say.
So we can't just say that because a particular subgroup has
100%
Subgroup is different. Subgroup refers to population subgroup. What are you referring to?
उसमें से जो स्कूलिंग
when we compare let's say standard account rate from
स्कूल अटेंडेंस उसका कंट्रीब्यूशन जो है
Different population subgroup. Yes.
डेप्यूटेशन में टोटल डेप्यूटेशन वेयर हेल्थ वाला जो इंडिकेटर है उसका कंट्रीब्यूशन है कंपैरेटिवली से कंपैरेटिवली ज्यादा है
Compared to another subgroup.
हेल्थ
That is comparable.
that is comparable. But we can't just say like
But we could not say that contribution of schooling is more for tribal compared to contribution of sanitation for another. That comparison you cannot make. But you can compare. So these are 1/3, 1/3, and 1/3. So if in this one, I would definitely say that the health dimension has more contribution in Borishal than in Jinotega. or health dimension has more contribution, even the education dimension in genotheta, because both they all have one third, and one third. They have equal weight literally. So in that way, they are compared.
However, we can compare, let's say, rest of the student among different population groups.
You can, because they all have same weights. Yeah. Makes sense. But if you are comparing these different indicators for different groups, just bear in mind, it's not magic. Because you have assigned more weights as well, that needs to be acknowledged, and sometimes people do not acknowledge. Make sense? Any other questions? Yeah.
So we can say that Bangladesh is more health deprived than
Relatively. It's a relative contribution, right?
Yes.
If you have same level of M0, they are comparable directly. But suppose Bangladesh's M0 is 5 times larger than another. Say you compare, you will understand better Bihar and Kerala. Bihar's MPI is large, Kerala's MPI is small. Now, it is possible that even in small Kerala, some of the dimensions are contributing higher. But even that contribution in absolute sense is really, really small. Whereas Bihar, something small contribution is actually much higher. So you have to be careful. But with similar M0s here, yeah, you could say nutrition is a bigger problem. Our health is a bigger problem in Bangladesh than in Nicaragua. That you can say. That health is contribution more to poverty in Bangladesh compared to that in Nicaragua. Sounds good?
It can also be stated that standard of living contributes a higher.
Louder, I cannot hear you.
I was just saying that if we say that this health contributes to a larger extent towards multidimensional poverty in Bangladesh, so from that graph we can also say that in case of Nicaragua, the standard of living has a higher contribution.
Yeah, sure. Absolutely. No doubt about it. Yeah. Okay. Now we move to population subgroup, but this is something you have already seen. Yeah, this is not new to you. So suppose we have this population subgroup where suppose we divide them into male and female. Yeah. So you have Akash and Virat, and then you have Aisha and Maria. Now I'm using a different poverty cutoff just to run this exercise. So if you have a poverty cutoff of 0375, then of course 3 of them will be identified as 4, multidimensionally 4. Now you have Akash with no deprivation, you can see Virat over here, then you have Maria, and then you have Aisha. Okay. So now if you compute the multidimensional head count ratio, so overall, of course, 0 plus 3.75, 1 and 0.5 divided by 4. So 15/32 is going to be your overall M0. And then for male, it is 0 plus 1/2, 0 and 1/2. And then for female, for Aisha and Maria, 0.3745 plus 0.5/2 is 7/60. So that's the M0 you or the adjusted head count ratio you get for different groups, right? And now, what is decomposition? So what will it give? Your population share of 50%. Population share times half, which is for male. Female population share times female adjusted head count ratio. That's your overall head count ratio, 15/32. That's it. Yeah. That's what? Yeah. 15/32. They're the same. So you add them up, you get back the figure. Yeah. So because male and female have population share of 0.5. Make sense? You see these two kinds of decompositions that you can do? Okay. Now, it turned out that if you have for this population decomposition, your multidimensional head count ratio can also be broken by the same. So, multidimensional head count ratio is also, decomposable by population subgroups.
Is it possible for intra-household relationship between the group share the same? Is it possible for the intra-household analysis because they both share the same?
Clarify the question because your question is not 100% clear. I will tell you why, but try it again. And a bit louder.
I'm asking, is it possible for intra-household analysis between male and female? Because the household share the same resources.
Some resources, yes, but they do not share all deprivations, all achievements, do they? Education, do they share education? Do they share health? Yeah, so it depends on if you can select the indicators accordingly. But yes, there are some indicators that are same exactly across household indicators. So there are some work going on in UFI has tried to do some sort of work, but it is not 100% certain in that sense. Some indicators will be exactly the same for male and female. How do you differentiate? Yeah, so you will get same value for some indicators, but some other indicators. So ideally, you should try to select the indicators that are different, because otherwise, in most indicators, they'll be exactly the same. Only in some indicators, there will be one or two indicators you will have the difference. You have to be careful. Yeah. Okay, so once you have population decomposition, what you can do, if the population shares do not change, you can always try to understand, changes by subgroup. Yeah, so this is one paper we wrote using the data between 1999 and 06, and it turned out all the subgroups that were lagging behind, to start with, their poverty reduction was slower. Of course, my colleagues along with Sabina again did the analysis. They redid the analysis between 2006 and 2016, but they got the opposite conclusion. Yeah, poorer subgroups had a much faster reduction during that period. Okay. Now, slowly, what we will do, we have around 40 more minutes, and I wanted to do some other things. Questions so far about the methodology? Is it clear? Share. Average deprivation share. So you have for the multidimensionally poor, you have the deprivation score. Yes. For the poor, you just take the average. Yeah, that's average deprivation score. What else would it be? So you have these two for multidimensionally poor, only those who are poor. You take their deprivation score, divide by.
So,
Yeah.
if we were to extrapolate our results for larger groups,
Extrapolate.
yes, I mean,
What does that mean?
if we have a sample for a particular district,
Yeah.
and then if you want to like normalize the results for the district, or say that we want to like say that the district has this level of deprivation on certain indicators. So, what do we do in that case?
I can follow your question.
So, in case of NFHs,
Yeah.
we have certain weights on particular.
What weights are you talking about? Sampling weights.
Sampling weights, exactly.
Okay.
So, when do we include them in our analysis? Do we need to include them in our analysis? That is the question. In order to like analyze
Did you understand what Pratap did on second day? The use of sampling weights in NPC.
Sorry.
Pratap talked about sampling weights
Mm-hmm.
on Tuesday when you were showing this data. Did you understand that?
No, sir. I mean, you can repeat it once.
That's what I'm checking, because if you did not understand, then the level of repetition will be different, right? You
Yes.
did not follow what?
Yes, sir. Please.
What you did?
No. I mean, I did not follow it.
Okay. So the idea is that you use sampling weights because sampling is done using data. Ideally, if you want to do random sampling, what is random sampling? You suppose have a bucket of red balls and black balls. You close your eyes and you pick up, that's your random sampling, right? So if you have 80% red balls, 20% black balls, and you close your eyes and pick up 10 of them, you are supposed to get 2:8, right? That's the idea. But we cannot do that when we are doing sampling in a country, right? So because we have just one shot, we cannot just repeat that exercise 1,000 times. We have one shot, we have to make it representative of the entire country. So we divide the entire country into strata. And then we collect randomly people from each strata. So as a result, we collect sample from the entire country. That's the idea, right? Now think of state of Karnataka, or state of Uttar Pradesh, and state of Goa. Which one has larger population?
Uttar Pradesh, obviously.
Now Uttar Pradesh population could be 1,000 times more than Goa, but that does not mean you collect 1,000 times more samples from Uttar Pradesh.
Okay.
You collect 100 from Goa and 120 from Uttar Pradesh. But then 100 people, 100 samples from Goa is representing a smaller fraction of population. But 120 people from Uttar Pradesh, they are representing a much larger group of population.
Yes.
So whenever you are computing something at the national level, you have to inflate UP's population 1,000 times. The sample you have to provide, so you have to put 1,000 times more weight on those samples compared to Goa. So if you want a nationally representative estimate, this is my average per capita monthly expenditure, or this is my average, this is my adjusted headcount ratio of the country. And if you do not use those weights, you will get wrong estimates.
Okay. So I mean,
Is that your question?
so yes, my question is about at what stage of this calculation, this whole methodology, we use those weights in our computation of.
Whenever you are aggregating. So why don't we come to the afternoon session when we are doing stata?
Okay.
So when you will be doing stata, we have to compute those. But do you understand the concept of
Yes.
sampling weights now?
Yeah.
We'll be talking about those, and I will show you how to use it in the afternoon when we are doing data exercise.
Sure.
Yeah. Any other questions at this stage?
The graph you showed.
Which graph?
We had where we had 3 regions and the contribution we are giving weights to different dimensions. Equal weights to different dimensions, and within dimension there are. So on the y-axis, what's the contribution here?
100%.
Sampling
What is the y-axis?
100%. The contribution of this particular indicator to overall NPS.
weight लगा के हम कैसे calculate करें लाभ
Contribution of a particular indicator to the indicator.
adjusted measure
Is it clear? Is that really just your question?
Yes.
Okay.
adjusted
Any other questions?
adjusted
In stata or just in here?
वो जब कंप्यूट करेगा
The multiply headcount ratio and intensity power
should
be consider the adjusted headcount ratio or
पहले calculation में not है
where we calculate the
स्टिकर्स में कंप्यूट करना head count
Please
adjust
Sorry, I'm a bit slow. Probably I'm talking too much. Please repeat.
should we consider the multi headcount ratio or adjusted headcount multiply headcount ratio and intensity. So we get the multi-dimensional poverty index.
So you are saying we multiply multidimensional headcount ratio and deprivation share to get the multidimensional poverty index. Then
Should we multiply the adjusted headcount ratio with the intensity or multi-dimensional?
So if you multiply multidimensional headcount ratio with adjust average deprivation share, you get the adjusted headcount ratio, which is the multidimensional poverty index, right? What is the question again?
My question is, should we consider the adjusted headcount ratio or
I have no idea what you are asking.
और यहाँ MPI भी निकालते हैं तो इसके बाद बोल रहा है कि वेट लगाने की नहीं
You have, this is your adjusted headcount ratio, which is M.
ये करके ये
It is equal to your multidimensional headcount ratio
करेगा ना तो डिस्ट्रिक्ट वाइज में
times average deprivation share among the people. What is the question?
my
डिस्ट्रिक्ट
question
वाइज
is,
ये मान
like when we calculate the multi-dimensional
तब उसका
poverty
डिस्ट्रिक्ट
index.
उसका वेट
This is your multidimensional poverty index.
खत्म करके ये सारे कैलकुलेशन खत्म करके
So we calculate it by multiplying the headcount ratio.
This is your headcount ratio.
और क्लियर
So here we consider the adjusted headcount ratio or multi-dimensional.
गलत तो नहीं होगा ना
Again, I repeat back. Let's slow down, yeah? This is your adjusted headcount ratio.
मुझे
This is your
वेट
multidimensional headcount ratio.
बिकॉज़ वेट
And this is your average deprivation share.
हाँ डिस्ट्रिक्ट वाइज कुछ जो
Again, what is your question? This is adjusted headcount ratio is equal to multidimensional headcount ratio times average deprivation share. Question again?
So then we calculate the multi-dimensional poverty index.
And what is multidimensional poverty index in your world? So multidimensional headcount ratio in your poverty intensity. And you have your the multidimensional poverty index, which is adjusted headcount ratio. Question?
Multiple poverty index is the headcount.
Yes.
इसका कैलकुलेट कर लिया इसमें वेट लगा दिया तो ये
So your question was
Adjusted headcount is equal to the multidimensional poverty
या
index.
फिर स्टेट का
MPI. MPI uses this methodology to compute.
वेट लगाया
Okay, so you are talking about multidimensional poverty index, which is MPI. This is MPI, but this uses a particular set of indicators, particular set of dimensions. This is the methodology itself. The adjusted headcount ratio is a methodology. This methodology has been used to construct the multidimensional poverty index, but that is the main methodology. This is a particular adaptation of the index. So when you look at them, MPI, it says this is equal to a product of incidence and then times intensity. Okay? This is intensity and this is incidence. So this is multidimensional poverty index, this is intensity in incidence, and this is intensity. Okay? So I just taught you the methodology now. Did that answer your question? Okay. So now we move on in the last half an hour about some additional things that we do. Yeah? We have done the methodology. It's clear now what the methodology is. Yeah? So now the question is, it is useful because your parameters may change. Your poverty cutoff, very hard to defend, just like poverty line. Your weights, they're very difficult to defend because any weight you choose, somebody will come with a different weight. There is no particular way of selecting weights. And again, let's not make anyone fool you around that I have a perfect way of making weights. There is nothing called perfect weights. Yeah, all depends on value judgment. So what you need to do, these are available in, I think, if I recall correctly, chapter 8 of your book about the robustness, discussion on robustness and standard error. So standard error, confidence interval, t-test, I cannot show you without data. So we will come back to it in our final lecture session today to show you how to conduct those tests. Yeah, chapter 8, it's written here. Sorry. So why is statistical inferences important? Is suppose you have this example, say Goa versus Punjab, okay, and then you have Maharashtra versus Tripura. So both have a difference of 0.31, right? The difference here is 0.31. Difference here is 0.32. The same, right? The difference is same, but it turned out one is statistically significant. If it is statistically significantly different, you can say Punjab's multidimensional poverty index is higher than that of Goa's. If they are not statistically significant, you cannot make that statement. That means Maharashtra and Tripura, they have no statistically significantly different. So you cannot say that Tripura's multidimensional poverty index or adjusted headcount ratio is higher than that of Maharashtra. We cannot make that statement. So unless you compute the confidence intervals, unless you do the t-test and comparisons, you cannot make a statement that one value is higher or lower. They're indifferent. Right? That's what we do in econometrics as well all the time. Is it clear? Okay. I will give you an example. What we have done is from another paper that I did with my colleague Shugata Bhatt at Delhi School of Economics. So we were studying deprivations. It was kind of standard of living, we call it, but it was in Indian set of slums from 3 metro cities: Delhi, Mumbai, and Kolkata. So it is based on a primary survey. And we were constructing our own multidimensional indicators, but at the slum level. Now, we could not just use global MPI. So we had to define our set of indicators. Again, we tried to justify why we are doing and so on. It was published in Social Indicator Research. Yeah. So we had 5 and 6, 11 indicators total. Yeah. We did not use any unequal weights. We just used simple counts. That means we provided equal weights to them. Yeah. Okay. So what we did instead, this is the first thing we did. We did not just construct an index. We did not set any profit threshold. We did not equal unequal weights or anything. Yeah, just take the indicators, count them. 1 to 11. No weights, no poverty cutoff. Yeah. Instead, what we did, we just plot them, plot the distribution. So how you do it? You can see. So these are for different poverty threshold, right? 1, 2, 3, up to 11. And we just plotted, this is the population of slum dwellers. That means the incidence. This is the head count ratio for different cutoffs. The multidimensional head count ratio. If you do the multidimensional head count ratios, you can see that if you take Mumbai, the graph is mostly below that of Delhi and Kolkata slums. So lower multidimensional head count ratio for all, yeah? But if you look at Delhi and Kolkata, you have some intersection at the top. You cannot make that comparison. But for this other part, at least, no, yeah, Delhi is slightly lower than that of Kolkata slums. Okay? And of course, we had to use weights, sampling weights, because from different pockets, different wards in from Mumbai, Mumbai has wards, right? 24 wards, if I remember correctly. So we collected slum data from different wards, and different wards represented different slum population. Because all wards, they do not have same population, same slum population. So we had to adjust with that number. Same thing we had to do it for Delhi. Same thing we had to do it for Kolkata. And this is what we get. So it gives me kind of the picture of for what region Delhi has lower than Kolkata and Mumbai has lower than the both. Yeah. Then we compute the adjusted head count ratio. This is the MPI equivalent. But this we cannot call it MPI because we have different set of indicators, different weights. We cannot call it MPI. But it's the same methodology. So the methodology is the adjusted head count ratio or M0. Make sense? So when we do that, here, so in the previous one, we had only multidimensional head count ratio. Here, we have multiplied the multidimensional head count ratio with average deprivation share among the poor for each cutoff. Yeah. Now you can see, you can get a clear ranking. Okay. Okay. Can you call yourself Shumon Shet? Why not? We both are human. That's fine. So methodology is adjusted head count ratio. Right? Both are adjusted head count ratio, but they are different names. MPI is a name that came up by OFI and UNDP. I said here, I did not say this is MPI. I said MPI was constructed using this methodology. I am a human. My name is Shumon Shet. You are a human too, but with a different name. So adjusted head count ratio, the both are adjusted head count ratio, but they both are not MPI. MPI has a particular set of indicators, 3 dimensions, 10 indicators, particular weighting, particular poverty cutoff. You can use them. Why keep all in MPI? See the meaning. Is it clear or do you disagree with something?
But we see that they're using here adjusted head count ratio.
Adjusted head count ratio is the methodology that has been used to construct MPI. Okay, so MPI is one form with particular set of indicators, weights, and everything of adjusted head count ratio. Adjusted head count ratio is the main methodology. Does it make sense? So this is, so when you write this M0, M0 is not MPI. NPI is one particular adaptation. You can come up with your measure, an energy poverty, multidimensional energy poverty. We are not going to call you NPI energy. What do you call your multidimensional energy poverty? This multidimensional energy poverty, MEPI then. Not MPI, just different name. Make sense? I think that was your question too. MPI is a particular name. It's a methodology. So I use the same methodology here. So I can call it adjusted headcount ratio. Anything can be called adjusted headcount ratio because it is adjusted headcount ratio. Yeah, but for slums. Yeah. So now, when I use for the adjusted headcount ratio, you see I get a clear ranking. There is no intersection at all. So up until this part, of course, you have to check for sampling standard errors. I will show you in the next picture.
Sir, adjusted headcount ratio is calculated by considering all the indicators like derivations. So how did you visualize this by considering only one? It started from one indicate.
That means if a poverty cutoff is one. So somebody is multidimensionally poor if the person is deprived in at least one indicator. Do you remember when I was computing, I had a poverty cutoff of 0.5, I got an adjusted headcount ratio of 6/16, but then I changed it to 0.375, I had a different value. Remember? Same way. So I'm changing the poverty cutoff. It is identifying different group of people. Average deprivation scored among the poor is going up, and so on. Yeah? There you go. This is how it is. Yeah.
So here, like Mumbai has less poverty as compared to other in terms of adjusted headcount ratio.
So in terms of adjusted headcount ratio, whatever cutoff you use, Mumbai adjusted headcount ratio is lower than that of Delhi, which is lower than that of Kolkata. Yeah, it's a kind of M0 dominance in that sense, adjusted headcount ratio dominance. So I did not use, in the entire paper, we did not use any particular poverty cutoff because I know that whatever I use, you will come and ask me, why did you select this poverty cutoff? We said, we are not using any. Yeah, the entire thing was based on dominance. And I did not use unequal weights either. People may come and tell me, why didn't you use unequal weights? I will ask that person, please tell me what I use. Whatever you ask me, I will just test for it. And it turned out, I did that experiment, no one agreed. I said, you didn't agree, so I used equal weights. Okay? Less controversial, right? Because look, whatever I do will generate controversy. So let's not do anything. Yet I am getting good ranking. I'm able to show that which slum is performing better, which slum in which city is performing better. Yeah. Yeah. Just wanted to show you an example. Any other questions? Yeah. Okay. One.
On this vertical axis,
Yeah.
both are scores, right?
That's the adjusted headcount ratio. Yeah.
But actually, here, it will just differ some slides that how can you just
Statistically significant.
yeah?
I will show you next slide. Just give me 1 second. Yeah. Yeah.
So what is the unit of this adjusted headcount ratio?
Between 0 and 1. It's a product of 2%. It lies between 0 and 1.
Yeah, but headcount ratio to percentage of
Just no, I mean, it has an interpretation I can give you, but it is confusing. So it is just a number, just an index. So it has 2 percentages, right? Percentage of people poor, percentage of deprivations. Yeah. For example, when you compute area, length, and say base, yeah, you have the unit is centimeter square. So ideally, it should be percentage square. This is how it should be. It just makes things complicated. So we just say points. So if you have a reduction of 0.05, you say a reduction of 0.05 points. It can be presented in percentage term, but it's a bit confusing. I'm not just taking you there.
I've seen a few papers that have shown this away percentage or but
Okay, technically, I'm giving you the technicality, but I do not want to raise questions here. So I'm not going to spend 10 minutes answering that questions. Yeah, I'm just saying, and we'll stop it. So if you have an MPI value of, or an adjusted ratio value of 60, so it is the 60% of all deprivation had everybody in the country would have been multidimensionally poor and deprived in all impairs. How does that feel? I'm not going to answer any questions regarding this. I'm not going to repeat this, but this is how it is, but it is very confusing. I know how to do it technically, trust me, but not always technical accuracy does not always mean it will be very intuitive. Yeah. Think of a situation where everybody in the society is just deprived in all dimensions. What would be M0? 1. Then if you have a value of 0.6, then it is the 60% of the situation in a society where everybody would have been deprived in all dimensions. It's 60% of that ideal deprivation. Doesn't make much sense. Just keep it 0.6. Should be fine. Yeah. Everything has this kind of intuition, but it's not always all of them are policy development. Okay. So here is another example. So it was the percentage of population poor subject to the MPI poverty cutoff. It was a paper with Sabina Alkar. I think it's for the India one, change in India one, 1998 and 2006. Now you can see it's a bit small, it's a bit difficult to see. You see, this is the difference. The difference is presented there. But then you have the confidence intervals, even though the data set was very large, the confidence interval is very tight. So you can see the confidence intervals presented there. That means the difference is there is dominance, but we know that these dominants, they are statistically significant quite up to here. Then at a really high level of cutoff, we do not have any statistically significant. This is exactly what you are asking.
No. Actually, I was referring to that Mumbai score is below
Delhi and Kolkata.
So for that, I think you might have tested that serious level.
Yeah, but this is what I'm showing. Yes, you have to do. This is the one is below the other, but that's the difference in statistical significance. This is what I've done. This is what I'm showing here. That dominance analysis with statistical inferences together. But yes, yeah, we did that in the paper. I just didn't show you in the graph. But of course, you have to do. This is what exactly I'm showing. You have the dominance, but then you have the differences, whether you are saying statistically significant or not. If the confidence interval had crossed this 0 line, they will not be statistically significant anymore. Make sense? Okay. Now, dominance analysis. If you have dominance, home free. Very good. But you saw for Delhi and Kolkata, I had intersection, crossing at some points. So of course, I cannot do dominance analysis. Dominance analysis may not give me the ideal result all the time. Suppose you have 100 countries. If you have to do pairwise dominance for these 100 countries, comparing each pair with the other, massive. Sometimes what you can do rank robustness analysis. Yep. So rank robustness can be done for, say, you want to select, you have your one weighting scheme, but you want to test the robustness with respect to 5 or 7 other weighting schemes. Possible, right? You select 5, 10 other weighting schemes, and you again generated the currently ranks. Or for India, you are doing, or district level, you are doing. You have one set of weights, you rank all 600 districts, but you change the weights or change the poverty cutoff or change the deprivation cutoff, and you want to check if the ranking of the districts, they're robust or not, or how many of the rankings they're changing, flipping. It's good to know, right? For policy purposes. So what you can do in that kind of situations, you recompute your M0s, or your multidimensional head-count ratio, whichever measure you are doing. And then you can use the rank correlation method. Please do not use Pearson's correlation method. It just gives you a linear measure of correlation. It's not good. So Spearman's rank correlation can be used. Many of you probably know about Spearman's rank correlation. You have to just give the Spearman. But I always prefer this one, Kendall one. And I will show you why. What is the intuition of Kendall? Yeah? Or you simply look at percentage of robust comparisons. You take the values, and you for every bit you look at the robustness using confidence intervals and so on, and standard errors, and you report, okay, I have these 30 regions. So 30 regions means that many pairwise robustness comparisons we can have, and of all the possible pairwise comparisons, 80% of them are robust. That gives you a good sign. Okay. So this is what Kendall star rank correlation is. So what you do, so suppose you have 10 countries or 10 regions. 10 regions means if you use perfactorial, combinations and all those things, you should have 45 pairwise comparisons. Am I correct? Ten C2, 10 combination 2, 10 C2, 10 times 9 over 2, 45, right? So we had to do that for 100 countries. You can imagine how many. 100 times 99 divided by 2. Okay? If you are doing at India state level, 29 times 28 divided by 2. That many comparisons. Yeah? So what does Kendall do? So suppose you have these two different weight 1 and weight 2. Yeah? So you rank the states by weight 1. You rank the state by weight 2. And in you compare each pairwise comparison, because you have 10 states, you have 45 comparisons, pairwise comparisons. So you note down the concordant pairs. So if, say, West Bengal is better than Bihar, you have weight A, West Bengal is better than Bihar, West Bengal is better than Bihar. So that means they are concordant pair. They are agreeing. But suppose for another region, say Gujarat and Maharashtra, Gujarat is better than Maharashtra for one, but Maharashtra is better than Gujarat for the other. That means disagreement. They're discordant. So you have concordant pairs and discordant pairs. Kendall-Star rank correlation is the difference between the concordant number of concordant and number of discordant pairs divided by the total number of comparisons. So if you have perfect positive association, because your ranks are perfectly positively correlated, right? Whoever first here, first there, second there, and so on, you will have all pairs concordant, no discordant pairs. So this will be equal to 1. If all pairs are discordant, that means they are just ranked in reverse. Here you have 1 to 10, here you have 10 to 1. You will have all discordant pairs, no concordant pair, this will be -1. Otherwise, for 0, that means somewhere in the middle. This is very intuitive. Tetrachoric correlation, I'll be happy if somebody can give me that kind of intuition for tetrachoric correlation. Here you know what you mean. Tetrachoric polychoric correlation. If somebody can come and tell me this is exactly what it is, I'm happy to buy. But if then people come, oh, I had this model and this model gave me results from the machine, I'm sorry, thank you. That's the difference. That's why I typically avoid, because if I cannot see it, look, if I cannot see something, how am I going to tell you what that is? Same thing for random forest model. If you can tell me exactly what it means, I try to show you every step, right? I'm not hiding anything. Everything is clear, yeah? And if I change something, I should be able to tell you how things are going to change. If you can tell me that, if you can show that to me, and you know every step, perfectly fine, please go ahead. If not, you'll be very careful. Here you know what is driving the contribution. The issue is that whether you could try to justify. Make sense? Is this one clear? The correlation? Yep.
The other day you read and the use of HTA is controversial because it uses Pearson's.
No. It's controversial because the dimensions, the correlations, the association between indicators, they're quite high. People used to claim that it's more than 0.7 or something like that.
But at the same time, it also uses Pearson's ratio.
No, they use speed uses different. It use some people use Pearson's correlation, some people use Spearman's correlation. I have used Kendall's correlation in my paper. Different people use different one. Whenever you have these ordinal ranks, Spearman and Kendall, they are as non-parametric, they're much better than Pearson's correlation, because Pearson's correlation depends on the linear relationship. It uses standard deviation and mean, right? And thinking about mean of the ranks and so on. So when you have rank correlation, is agreement versus disagreement, that's what matters. The distance between them do not matter. You see? But Spearman, Pearson's correlation only gives you a particular linear relationship. Actually, when you have, I guess, a fewer observations, then Spearman and Pearson's, they tend to converge in limits. So I always prefer Kendall because I like the way, you don't have to just compute the linear relationship at present. Here, literally non-parametrically, you just see concordant or discordant, they are agreeing or not, and then you're presenting the results, you can see it properly. What was your question about?
No, I got my answer. That anything which assumes Pearson's population coefficient, it is due to linearity, and assuming too much of linearity is just not.
Why should I assume linear? I mean, the relation could be concave or whatever, but still, there is relationship. Some of them are agreeing and some of them are not, right? But Pearson will just tell you if something is not linear, that means no relationship. Although some pairs are agreeing and disagreeing, even though the relationship is like that, it does not, right? And that's why we need to go to copula, because copula, what they do, again, is another different statistical tool for exploring joint distribution. You can explore whether you have this strong association in the middle or in the tail and so on. So you can do different, but it's completely different statistical tool for understanding association. Yeah, that's mostly used for simulations and stuff. Any other questions?
So dominance analysis is conducted by changing the poverty cutoff or by changing the weight?
The one I showed you, it's changing the poverty cutoff.
We can do both.
Weights here, the problem is that the multidimensional poverty index, because if the censored headcount ratios were independent of weights, you could have conducted dominance analysis. But what happens is that every time you change weight, your identification changes. And that causes a change. So it's kind of an endogenous way in that sense. So the type of dominance analysis that we know for weights, selection of these weights, range of weights, and so on, cannot be done here. If you use union approach, only then you can use that triangle thing, type of robustness test, which can be done. But without that robustness, direct robustness, dominance kind of analysis is very difficult. Yeah. So poverty cutoff, yes, dominance you can do. But for weights, you have to use this rank robustness analysis. Select different weights and then look how much the rankings are changing. That's the way to go. Yeah. Yep.
Can you just explain the confidence intervals of those using the two different weights? So how so it can explain.
I didn't understand your question, so how can I explain?
Actually, suppose there are two adjusted n.
Yeah.
So
say for two different states.
No. That means using the two different weights.
Dimension weights.
Yeah.
Okay.
So basically, rather than using the data, Can you just explain that how can the confidence interval can be established and
Without data, how can I show you the confidence interval to be established?
yeah.
I don't know. I'm not a statistician. My understanding is that you have an estimate, you get the confidence interval.
Yeah.
You have another estimate, you get the confidence interval. And if you do not have to, if you just want to test whether the difference is statistically significant, run a t-test. You don't even need the confidence interval. Because even when confidence interval overlaps, you still can have statistically significant difference. If the confidence intervals do not overlap, it is definitely statistically significantly different. But even when confidence intervals overlap, even then you can have statistically significantly different. But it is better to be done. You should better do a t-test between the two. I'll show you how to do t-test in data session. Any other questions? Oh, sorry. Okay, I just move on. How much time do I have? 4 minutes. 5 minutes. Okay. So just to give you a snapshot how multidimensional headcount ratio, if you compute, this is MPI basically, and how if you have World Bank's approach, how they differ. You can see we do not observe any just positive correlation. There's too much noise if we do. Yeah. Okay. Finally, very quickly discuss if you are, having to understand the distribution among the poor, what you can do. MPI cannot do that. Yeah, because MPI has to, or the adjusted headcount framework, they have to bring particular decompositions. You have to make some sacrifice. You have to make some adjustment. Yeah. So given that you cannot do, okay, but let me explain the situation. Suppose you have a poverty cutoff of 3 and these are your deprivation score. And you can then understand why 4 people in bold, they're identified as poor, multidimensionally poor. Yeah. Now, suppose you have timeline 1 and timeline 2. Yeah. Clearly, one person definitely has come out of poverty. Other people's situation has improved. But one situation is more poor than the other. If you compute the incidence and intensity, they are both exactly the same. But the distribution among the poor, they're different. So if you compute the MPI, you will get same MPI value here. If you compute MPI, is a particular index. Yeah. Or if say adjusted headcount ratio, if you use adjusted headcount ratio, you will get exactly the same value because you have the same incidence and you have the same intensity. But these two situations are different. Yeah. So here's an impossibility result. The impossibility result is, and this is the beauty of axiomatic framework. You are not saying it may or may be. You are able to say precisely when it can, when it cannot. That's very important for all of us. Yeah. So no multidimensional counting poverty measure satisfies symmetry, dimensional breakdown, and something called dimensional transfer. What is a dimensional transfer? It is if you have one situation like this, right? And you move to something like this. Here, you had high correlation here, 001 and 001, they are ranked equally, right? Here, they are not. So you moved from high correlation to low correlation. You should have change in multidimensional headcount ratio. You have adjusted headcount ratio, right? It should be different, right? But no, adjusted headcount ratio is exactly the same. So adjusted headcount ratio is not strictly sensitive to this kind of situation, but they're important. How to capture the difference? So there are two possible way out. Either use a measure that satisfies dimensional breakdown and you use dimensional breakdown property, but use another poverty measure that satisfies dimensional transfer and ordinality. So James and Sabine Elker and James Foster, they wrote another paper, but I don't think they have published. They proposed something called M gamma measure, which is sensitive to inequality among the poor. Of course, then you cannot do dimensional breakdown. You cannot create those graphs where you see how much these indicators are contributing. So you have to choose one over the other. The other option would be just use a poverty measure that satisfies dimensional breakdown, but then use an additional inequality measure separately. To just understand. So OFI reports a particular inequality measure among the poor. If you go to their table, OFI table, they for each country they report this particular inequality measure. What was an inequality measure? So you could do that adjusted headcount ratio, but then you use a separate inequality measure to study, to look at whether the distribution among the poor is more unequal or less unequal. Yeah? I mean, you can do inequality decomposition as well, because sometimes people are also interested, whether there is convergence, whether our poverty reduction across different states, whether they have converged over time or not. So MPI values, whether they have come closer or they have gone further. Yeah, people may want to know. So how to do that? So of course you can use descriptive tools like this one, so that you take these MPI values. This one is for one for Madagascar, one for Rwanda. They are very similar MPI, H, and A. But if you look at the composition, the distribution of deprivation score in the pie chart, they're quite different. Different share of population have different types of deprivation. Yeah. So, question, what type of measure should we use? Okay, absolute, relative. Now, let us look at this deprivation score vector. Suppose everybody's poor here. Yeah, so you have 4, 4, 9, 9, and we have 1, 1, 3, 3. Which one is more equal? Which one is more unequal? First one is more unequal? Okay. So these are all deprivation score, right? So let's look at relative inequality across the deprivation score. So we use the generalized entropy of 2, which is coefficient of variation, basically. So coefficient of variation actually gives the first one to be less unequal, and the second one is actually, first one is more equal, second one is more unequal. Huh? You get it, right? But this is how it is. Yeah? Because in the second one, they are 3 times worse, but of course, they are not 3 times worse, right? That's the idea. Although you feel it's more deprived, more dispersed, relative, this is the problem with relative unequality measure, and especially for bounded variables, where you cannot cross the bound. Yeah, that's one problem. So whatever exactly you want to see, they are not showing you. Convert this deprivation score to attainment score, because we have survival rates, mortality rates, literacy rate, illiteracy, they're all same thing, right? One is shortfall and one is just, attainment. Now, if I convert to attainment, 1 minus 4, 1 minus 4, they have 0.6 and 0.1 and so on. Now, which one looks more unequal? Which one looks more equal? Okay. Now, if you compute, this is what you get. Okay. So if you use relative, you see the comparison reversed. Now you tell me whether you look at survival rate or attainment rate or deprivation score or attainment score, they should just be differently unequal only because you have changed the sites? Would you rather accept that? So you'd have to reject relative measures. Relative measures cannot be used here. Yeah. So there is some idea called consistency. The idea of consistency is that if you just take the complement of something, inequality should not change. And if you have that, there's a lot of proposal in the inequality measurement literature that suggests use an absolute measure, because absolute measure will not change. It will give you the consistent evaluation. So again, Sabina, we worked at some point. This paper was published on research in economic inequality. So what we suggested using these absolute measure. Now, if you look at inequality among the poor, remember the formula for variance is sum over xi minus x bar whole square, right? What is x bar? It's the average deprivation score among the poor, which is A. So you have the censored deprivation score minus A whole square, so that gives you the inequality among the poor. What is the value of alpha? It turns out when the maximum value is 1 and minimum value is 0, if you have that kind of distribution, the maximum possible variance, maximum possible attainable variance is upper bound minus lower bound divided by 2 whole square. That's the theoretical maximum upper bound. So you can adjust this value of alpha to get a value between 0 and 1. That's right. And this one, the next one, you can use similar formulation to compute. This is regional disparity. So you have M0s of different regions, and this is overall M0. And then you can have a measure of regional disparity in terms of an absolute measure. Okay, practically, does it make any difference?
The paper is on the source that said in August 2017. That paper is on the source, please.
Should
The
be.
paper which you.
Yeah, it should be. If it is not, I will make sure it is listed. Yeah, but it is given in the slide at the beginning of the slide as well. At the beginning of the slide, I had the source mentioned. So here you have comparison between Yemen, India, and Tokyo and Bangladesh. You can see. There we go. Very similar level of M0. You could call it MPI because taken from MPI indicators. But then if you look at inequality among the four, they are quite different, right? If you have A, quite similar, they're statistically significantly different. Yeah. Then you look at no, the regional disparity was quite similar actually with 21 and 22. Similarly, look at Togo and Bangladesh, again, similar level of MPI, similar number of regions, look, regional disparity, very different. So it gives you an additional tool, so you don't have to sacrifice dimensional breakdown. You can still use breakdown, yeah, dimensional breakdown, but then you can use this additional inequality measure to understand inequality among the poor as well as regional disparity. Sounds good? Okay. Just moving on, I think this is the final slide. If you look at the main paper of Algar and Foster, you will see there is adjusted headcount ratio, there is adjusted poverty gap, there is adjusted square poverty gap. What they do, they use the same identification, but I mean, it just includes normalized gap and normalized gap square. So poverty gap and square poverty gap. You already know what they are. They just extend the framework. So all these all these ones are replaced either by gap or by square gap, depending on whether you are computing adjusted poverty gap or adjusted square poverty gap. Identification is exactly the same how I have shown you. No difference in identification. Identification is done with 0, 1. Yeah, and the weights. Caution is that suppose you have that measure, you have some indicators as continuous, education, income, and so on, and some indicators are categorical or binary. Now, how do you compute gap for categorical variables? You may have these numbers 1, 2, 3, 4, but you know they do not make any sense. For binary, the problem is even serious. For binary, what happens? So suppose you have some indicators are continuous, so suppose income, and then you have access to electricity. Yeah? This one you have continuous variables, but this is just 0, 1, 0, 1, right? So here, if you compute the gap, it will be z minus yi over z. If you try to compute the gap here, it will be z minus this identity function over z. Now z is going to be 1, right? So this is literally either, so this one, the gap is going to be 1 minus 0 over 1. Always 1. Now, when you are doing z minus y or z minus yi over z whole square, given that these values are less than 1, the squares will be lower, lower, and lower, right? This one will remain exactly the same. For adjusted headcount ratio, this will be 1. For gap, this will be 1. Square gap, this will be 1 always. So what happens if you mix those indicators and apply, then their share to overall poverty, that these indicators share to overall poverty will keep on increasing over time. Because their values are just going smaller, smaller, and smaller. From 1 to fraction to square of a fraction. So you have to be careful applying adjusted property gap or adjusted square property gap on top of whatever you are doing. Second, ordinality property would be violated because here you need cardinal numbers to get the gap and square gap. And if instead of y you use root z, root y, root z, all your measurement will change. Now, for adjusted head count ratio, they are not a problem because you are in 0-1 world. So even if you change them, your identification is not going to change. That's why adjusted head count ratio satisfies ordinality. They don't. Who is speaking? Which alkyl phosphate? They all are alkyl phosphate. They are all alkyl phosphate. Which one are you talking about? This one is alkyl phosphate. This one is alkyl phosphate. So adjusted head count ratio alkyl. They are all alkyl phosphate. Which one are you talking about? Adjusted head count ratio. Name it, man. I just taught you. Adjusted head count ratio. Ordinal is also the one, right? So if you change, if you take this kind of monotonic transformation, square root, square, wherever you do, that 0-1 identification doesn't change. So it satisfies ordinality. It works with ordinal variables, but gap, square gap, you have to be really careful. They don't. They all are alkyl phosphate. Different classes. Adjusted head count ratio satisfied, others don't. Again, whichever you use is totally your choice. I'm not going to dictate you. My task is to empower you knowledge what they can do, what they cannot. Now you have the knowledge, you choose. It's your world now. Okay, but just know which one can do, what things. Okay, stop here. We'll meet after lunch. We have 1 hour. I will show you certain things. I will go through elasticities, how you can use elasticity and inclusive growth in multidimensional framework. And then I will talk a bit about impact evaluation. I'll just show you some results that I did in one of the impact evaluation papers. And then we'll speed up in the final session.